Page 3, reviewing for test over chapter 4, pre-calculus. You want to determine the amplitude and period of y equals 2 times the sine of 4x and graph the function. So the amplitude is 2. It's just the absolute value of this number here. To get the period, take 2 pi, which is the period of the parent, and divide by 4, because that's your coefficient here, and that would be pi over 2. So in order to graph this function, you can refer back to the original function, the parent function, y equals the sine of x. This was done in a previous video using the unit circle to generate these answers. It looks like this, and if we want to make an adjustment for the amplitude, we can just make sure that this number, instead of 1 as in the parent function, becomes 2, and this number becomes -2. And then you can go to your parent function, and the original period was 2 pi, but for this one it's going to be pi over 2. So you just change this to pi over 2, and then this point is halfway between 0 and pi over 2, so that would be pi over 4. This point is halfway between 0 and pi over 4, so that's half of 4, which is 8. And then here we have 1 pi over 8, 2 pi over 8, which reduces to pi over 4, then 3 pi over 8. And so basically that's all you have to do is take your parent function and make the adjustments on it, and then you will end up with a graph like this. I ended up adding some more to it by continuing the pattern. So here's one cycle, and then you can continue that pattern. You can go down again, up again, and just keep counting by eighths. So this was 3 pi over 8. This would be 4 pi over 8. And then 5 pi over 8, and then 6 pi over 8. Okay, to graph y equals 1/2 the cosine of x minus 4. The cosine function is different than the sine function, and in this transformation, we're going to have an amplitude of 1/2 instead of 1, and notice we have a vertical shift of -4, so that means we're going to go down 4. But we did not adjust the period at all because there's no coefficient here, so it's still going to have a period of 2 pi. So the original cosine function, if you remember, the cosine of 0 was 1. But now, with an amplitude of 1/2, the cosine of 0 is going to be 1/2, but then shifted down 4 units. So down 1, 2, 3, 4. So that's how I get this point here. And then if you remember the original cosine function, it went down, up, and so it finishes at the same point that it starts. So with the parent, the period is 2 pi, the cosine of 2 pi is 1. So if we make the adjustment for the 1/2 amplitude, and then we go down 4, we end up here. And then halfway is at pi. That's where we want to hit our minimum value. And it's going to be 1 lower than this because the amplitude was 1/2. So there should be a distance of 1/2 from here to here, and then a vertical distance from here to here of another 1/2. So this should be around -4.5. So you're going to go down, up, down, up. The next graph is y equals 2 times the secant of x. Now remember that the secant is the reciprocal of the cosine. So if you use your unit circle, the cosine of a 0-degree turn or a 0 radian turn is 1. So the reciprocal of that should be 1. So the secant is the reciprocal. However, this 2 here tells us I'm going to multiply this by 2. So the 2 times the secant of 0 would be 2 times 1, which is 2. Pi over 2. Go to the unit circle. Pi over 2 takes you to here. The cosine is 0. The reciprocal of 0 would be 1 over 0. Well, 1 over 0 is undefined, so that's where you're going to have an asymptote. Pi. Going back to the unit circle, the cosine of pi is -1. The reciprocal of that is also -1. 1 divided by -1, but we multiply it by 2 because of the 2 right here, and that's going to give us -2. 3 pi over 2. 3 pi over 2 takes you to here. The cosine is 0. Then that will be undefined. And then 2 pi. We're back to where we started. That'll be at 1 times 2. So the general shape of the parent function is like this. You're going to make an adjustment. If you look at the parent function of secant, it would go here, but we're going to be here. And so at 0, we're at 2. Pi over 2, we are undefined. 3 pi over 2, we're also undefined. At pi, we're at -2. And then to get these other values, you can do the secant of pi over 4, which would be the reciprocal of the cosine of pi over 4. And you can even punch that in your calculator and get a decimal approximation. Just make sure you're in mode radians. All right, for the last graph on this page, y equals 4 times the cotangent of 2x. The cotangent is the reciprocal of the tangent. So it would be x over y. So for example, if you are using the unit circle and you are at a 0-degree turn or a 0 radian turn, 1 divided by 0 would be undefined. So at 0, it would be undefined, and so that's an asymptote. So this y-axis is going to be an asymptote. You should know the general shape of the cotangent goes like this. And you can make a chart to complete the rest of the values. So for example, pi over 8. Now I ended up knowing that I had to go smaller because of this. So when I plug pi over 8 in here, 2 times pi over 8 is pi over 4. And so you want to go to your unit circle, and going to pi over 4, it's right here. And the tangent is going to be this divided by this. The cotangent will be this divided by this, will be 1, but then we need to multiply it by the amplitude, which is 4. So at pi over 8, I go up 1, 2, 3, 4. And then you can plug in pi over 4. When you multiply it by 2, it's pi over 2. At pi over 2, the cotangent is x divided by y is 0. So even after we multiply by 4, we're still going to get 0. And then you can complete the table to get the rest of the values. And you can use your calculator as well to help you with this.